are team number 13. So today we will talk about monitoring Spartina Alterniflora by using a self-supervised learning. So basically, this plant is declining due to climate change in the United States, but in China it has become a species separating quickly and harming local ecosystem. So our team focused on developing a self-supervised learning model to monitor the Spartan altum flora on the Atlantic coast of the United States and mainland China coast by using a satellite data with minimum in-situ reference data. So this slide shows has widely separating along a China coastal line, especially in certain provinces, but in the United States, it's found only in some area on the Atlantic coast of the United States. So now I'd move on to discuss the data part.
Okay, so we started off using the GLAD-R dataset, which consists of 16 date time series of globally consistent Landsat normalized surface reflectance. Basically, every 16 days, it has satellite images that are normalized to remove any distortions from things like clouds or differences in the atmospheric conditions. And it contains data from 1997 all the way up to the present. And then to actually select tiles from this data set, because of the huge quantity of data, we selected data from just 3 years, 1997, 2010, and 2023, and we looked specifically at regions with a high density of Spartina alterniflora. Then each one of these tiles that we selected is formatted as an 8-band GeoTIFF file. Essentially what that means is, as opposed to your normal image that has 3 bands, red, green, and blue, these satellite images are multispectral, containing information about higher wavelengths as well, such as infrared or ultraviolet.
So for self-supervised learning, we are taking 2 approaches. The first approach is the CNN object-based simple constructive learning, and the second approach is Dino V2, which is based on vision transformer pixel-based learning. For pretext, we define pretext task through the data augmentation, and we use ResNet 50 for simple constructive learning for vision transformer for Dino 2. And we build pipeline to optimize the performance by minimizing the loss. And for downstream task, we freeze the representation learned from the pretext, and then we incorporate UNet for simple constructive learning, PCA for the Dino 2 to visualize the results. And for the simple constructive learning, we visualize the results. We can see the training loss and validation loss decrease steadily, which means that the learning part of the pipeline works. And for the downstream, we can also observe that decrease of the training loss and validation loss, although we only trained 20 epochs for the representation learned from the pretext model. And so we conclude that this pipeline works for the task in hand.
So after using the first dataset, we noticed that dataset had a very low resolution compared to some others. And so we decided to use Sentinel images, which had about 3 times higher resolution compared to the Landsat images that we used before. And since we were looking for high resolution images, we also found this data set that is from the National Agricultural Imagery Program that had a resolution of 0.6 meters per pixel, but that was only available in the US. So we used that to compare how that would affect the results. After training the Dino model on 2 different datasets, one of them was Sentinel, and the other was the NAIP. We ended up with pretty satisfying results. As you can see, the models can capture some features here and there. So now the next step is to have or make some labeled data so we can evaluate how well the model does in detecting Spartina alterniflora.